Hello everyone, today we are going to do airplane room from TryHackMe. So let us quickly get started with our REST scan. There's our IP, and let me explain you the command. So the scan with the -a flags, we can specify the target IP. With the -u limit, we specify the speed of the scan, that is 5000, which is the recommended one by REST scan, or else your results will not be perfect. Then we have double dashes. So these are for whatever you specify after these double dashes will be passed on to the Nmap scan. So Nmap will run -a after it scans the available ports, and -on is used for, as you might know, exporting the Nmap output to the restscan.txt file. And quickly we can see we have two ports open, which might be a false positive based on the restscan usage, because restscan scans the port very fast and it may miss some of the ports, which happens quite often. So that is why I prefer Nmap right after I use the restscan. And that being said, I'm going to let this run, let this finish. After this finishes, we are going to run nmap scan again. Till then, we're going to focus on this port, and let us quickly see what we have on the browser side here. And instantly we can see it redirects us to airplane.thm host, and we have to specify that really quickly in our host file. So I'm gonna do sudo nano the host and specify that right here. So airplane.thm, and then our IP is this. Let's save that and refresh the page, and we should be able to see the page, and we do. First thing we should always check is the source code for any comments or something that may be just giving us some hints or some info, but that doesn't seem to be the case here. But we can see there's the background image contains a directory called static. So that is one thing we should note, that there's a directory named static, and there could be other ones also. And I'm just going to try if we can see the static directory or not. And it says not found. Maybe we remove the slash from here, but it just goes over to the Google. I'm gonna do something here, static again, and it says not found. So this must be some type of framework or something, because that happens in sometimes in Laravel, I guess, or some other frameworks, maybe in Flask also. So we'll see that, but we know that static directory exists, but it's just something that we haven't figured out yet. Our webalizer also does not tells us anything. But here we notice something, that there's a page parameter and it says index.html. So maybe if we can modify this page parameter to something else like etc password file in Linux, then we may be able to see the password file, but it says page not found. It might be because we have to specify that we are going up some directories and then etc password, and we get a file here, which once we open we can see it is the etc password file, and we can say we have a local file inclusion here. So we have the LF5 vulnerability, and let's see what users are on the system. So I'm going to search for bash, and here we can see we have Carlos and Hudson user, and also the root user, of course. So let's quick close that. So this is a type of LF5 payload. Our etc password was not working because maybe it was searching for the files inside that specific directory. So that is why we have to specify these dotted and black backslashes. And for the absolute beginners, I'm going to tell you, so if you're in a airplane directory, you want to go back, you of course you'll specify cd dot and then slash, then dot slash again to go back to directories, and you're in your home directory now, that is home Kali. Previously you were in the airplane directory. So that is how we were able to see the etc password file. Let us quickly see the nmap results. Here we have the results ready. We have port 22 open, OpenSSH 8.21 is running there. We have port 8000, and it is running Python server here. As we expected, this is a kind of framework, you can say. This is called Rugzig server 3.0.2, and I guess this server version does not have any active vulnerability that we can exploit right away. So we have to manually check if there is anything that we can exploit. Okay, so that is it. Now we are going to run the nmap scan again. Well, not again, for the first time, because this was a REST scan. So nmap, and then I'm gonna do a fast scan on the top. Wait, Let's just do top ports 1000. Well, let's just do all ports. And I'm gonna specify -A for the aggressive scan and -VB so that we can instantly see the open ports in the output. I'm gonna output the results to nmap. I'm gonna name it full so we know that we um, did a full port scan. Right, we have port 22 open, which we already found. So we'll let this run. Till then, let us take a look at this. Okay, so we got the LFI. Now if we want to see other files like etc hosts, we press enter, and another file is downloaded and we have to check it. So this is kind of a tedious task because you have to check each and every file again because it gets downloaded and your disk space, of course, it will be full. So I'm gonna cache this request in the burp suite really quickly. Turn on the intercept, press enter there, and for the request here, I'm gonna press Ctrl+R to send this to the repeater. Turn off the intercept, and then you have the request here. So if I click on send, we can see the output right away here. So there's no way, so there's no downloading of files or anything like that, and we save some time as well. We can also see the password file as we did previously here, and this is much better than before. Okay, now let us enumerate some things. So as we saw earlier that we had access, we saw that we had Carlos and Hudson user. Let us see if we can go into their SSH directory and fetch their SSH keys. So I'm gonna do, but before that, let us see who we are on the server. Because it's Python server, and Python server usually runs with the privileges of some user. It could be Hudson, it could be Carlos, or it could be root. So for that, I'm going to do proc self, I guess a CMD line. So proc self in CMD line means we are going to check the current process is a command line which was used to launch this program. And we can see Python 3 was used to launch the app.py program. So app.py is a script. It's a Python script, and it does not output the spaces here. So there was a space here. Okay, so we know that app.py is running, and app.py usually means it's a Flask or some sort of server based on Python, and it must be somewhere in the system. For example, it might be in some user's home directory. And so let us enumerate this a little bit more. Let's see what we are. So it's, I guess, proc self. I guess it's proc self environment, environment. Okay, this gives us the environment variables, and we can see we have the path variable here, but this is of no use to us right now. And we can also see our home environment variable, which says home Hudson, and log name is also Hudson, user is Hudson, shell is bin bash, and this makes it clear that we are Hudson user because our home directory is Hudson, log name is also Hudson, and user is also Hudson. Okay, that clarifies it. Now let us see if we can fetch the SSH keys from here for Hudson user. I'm gonna go home Hudson and then .ssh id underscore rsa, and it says page not found. id rsa.pub, we cannot fetch any of those. Okay, let us see if we have bash history. Maybe we can read the bash history file. It says no. Bash rc. Okay, we can read bash rc, but it's of no use to us because there's nothing that we can enumerate from here or could possibly take advantage of. But we know that, yeah, we can read the user's home directory. We could also have bash profile, but we cannot read that. If I try reading the bash rc file of Carlos user, it will say page not found because, of course, in Linux you do not have the access to other users' home directory. That is why we cannot use Carlos's bash rc file. But this makes it clear that we are Hudson user. Okay, all right. So going back a little bit, we saw that we had app.py file, and it could be in the Hudson user's home directory. So if I do app.py, it's not there because I spelled it wrong. App.py, it is still not there. Now, honestly, I'll tell you how I found it. One thing that you could do here is you could just send it to an intruder, or maybe use FUF tool to brute force the directories in the user's home directory. And this is where the fuzz would go, and you would just brute force the directories and find where the app.py resides or directory. But based on the past experiences of solving the CTF boxes, I knew that app.py usually resides in a specific directory because app.py has a lot of files with it, like static directory, templates, etc. So it usually comes under the app folder. So I just typed in app with the app.py in front of it, and it worked. And we can see here. So it was a bit of guessing, but that usually comes to your mind first when you have solved a ton of CTF boxes. And so, yeah. Okay, so let us read that really quick in the raw version. So it is importing Flask. We were right that it is a Flask server. So we have first root here and the second root here. So if a user browses over to the slash page, if it will check if page is in the request arguments, and if it is, it will execute this piece of code. Okay, so we can see we had a page here, argument here. So let's see what happens. So it is going to the static directory, and it's going to search for whatever we specify right here. We specified etc host. So this is why the LFI was there. So how this request was parsed was it searched for static slash, and then we specified dot slashes here, which is why it goes back to some directories and then searches for the etc host file. But when we tried like this etc password, it did not work because the static was mentioned here, and inside the static folder you do not have the etc folder. So that is why you have to go back a couple directories to make this thing work. So that is the reason why that payload worked. Now it also checks if this whatever we specify here is a file or not. If it is a file, then it simply returns it. Otherwise, it just says page not found. And if page this get parameter is not specified in the request in the URL, then it redirects us back to the index.html. Next, we have airplane. Let us quickly check that. We didn't check that. So if someone types in here airplane, and it just says let us fly. Okay, it renders the templates airplane.html. So these templates are usually stored in the templates folder inside the app folder. So if we go over to templates and then airplane.html, we should be able to see the source code of this HTML file. Let's fly, and then a couple of CSS to make this rotate and things. Okay, we have a ton of things enumerated till now. Nothing interesting so far to exploit the server and gain access or gain foothold on the server. Okay, so at this point, let us see what our nmap says. It is still running, so usually when it takes so much time, I run the rest scan again. Yes, I know it sounds a little bit weird, but I do it. Rest scan again, I run it, and you can see 6048 port pops up right away, which was not found earlier. If you say that it was found earlier, let me prove you wrong. Rest scan.txt, and we can see only 2 posts were found, 22 and 8000. So port 86048 is kind of new for us. So let us scan it and let us see what is running on this port. I'm gonna say airplane.thm port 6048 and -vv. I need a really good verbose output. I'm gonna cancel the above one, and we can also try netcat. We can try connecting to this port, and we have to specify the IP because netcat does not parses the domain name. If we specify airplane.thm, it will not work. 6048 port says connection to this port was succeeded, but what do we do now? Maybe some help or something. Okay, nothing comes up. 6048. We can try searching it on Google, what usually runs on port 6048. But you'd see nothing interesting there. So I'm not gonna waste your time because I did waste a lot of time there. It says X11 service is running there. X11 is usually the virtual monitors, or you can say it is a how you it's kind of like TeamViewer or AnyDesk. You can say you can connect your remote computer to see its screen or something. That is X11. But I realized afterwards that Nmap was wrong. It was not running X11. Now let us see how I was able to find it. So it took me some time, but we had to do that by the LFI thing. So as you know, we see the info of running processes in the proc directory. So if I do proc self, self means the current running process that we are interacting with right now, which is the Workzerk or Python server. Then we can see its CMD line, the CMD command, which was used to launch this process. If I do proc 1, we can see parent ID process once, C command line, which was used to launch the process, which is INIT, which is the very first process that launches when you boot your PC. Value 2, it says nothing. 3, 4, nothing. 5, nothing, because there is no process being run there. If I do 6, okay, so if I do blank, then I see boot image and console TTY, etc. Okay, so you can see that we have to kind of like brute force to see the list of running processes on the system, and we can see the command line which was used to launch the process. And why we are doing this, why are we doing this? This is the first question that may come to your mind. We are doing this to actually know what is running on the port 6048, so that we have an idea of what is running and then how we can exploit it, because it still says question mark. It is not sure if it is X11 or not. So we have to make a script, I believe. Let us try PubTool first here. Whoops. Okay, this is the URL here, and then cmd line. This is the command that we were using here, and we are fuzzing the processes. Now we need a list that will have 1 to maybe 2000 or 3000 um, lines or keywords. I don't know how to say that, but I believe I do have the code here. Okay, so this is a bash, simple bash command for I in sequence 1 to 5000. We are just extracting the, so we have the list of integers from 1 to 5000 in our pid.txt file. So if I see the pid.txt file, we have 1 to 5000 list of these numbers, and we can use this with our pid.txt. And if you're not aware of bash scripting, you can just search up your query in the Google or ChatGPT, and it will give you the same around the same output for getting this word list. Okay, let us run that, and that's a lot of output. And we have to filter based on the size, worth, lines. So we are gonna do that. Let's see. We can say it says size 0, but words are 1, lines are 1. Same for most of these. So let's see what comes up when we type in 16. So 16 is just blank. So we do not need blank output. So I'm going to filter out the ones that have size of 0. And let us see another one that says size 14, which is 35. So let us do that. 35, and it says page not found. We also do not need these ones. So I'm going to filter out the size 14 and the size 0, I guess. Okay. So filter size 0 and 14. Press enter, and okay, so I guess we almost have all of these valid ones, but we still do not see the command line from PubTool. So if we manually check all of this, it will take years. So that is why we need a script now. So I'm gonna copy this, and then okay, so ChatGPT here real quick. I'm gonna ask ChatGPT to create a Python script that will show the output of this command, but filter out the output, filter out the output, but do not show the output that has 0 or 14 size. Let us see what we get. Okay, looks fine to me. I'm gonna just use that one. So test.py, paste it here, Python 3 test.py. Okay, it's been a minute and we are on the 223 PID and we have a systemd, and there are still a lot of PIDs to enumerate, around 5,000, and it is gonna take a lot of time. So we're gonna tell ChatGPT to do another thing for us, that is multi-threading or parallel processing. Or I'm just gonna say make this script faster, and yeah, it's gonna use multi-threading. So we're gonna copy this code, replace it what we have. So nano, just remove the previous script and paste it here, Python 3 test.py. Okay, it should be a little bit faster than before, I believe. So we should see the 223 bit fast, and we do, yeah. So it's much faster than previously. Okay. We have a ton of output here, but I didn't see anything interesting till yet. It's the modem, network manager, and B5. Okay, we have the port 6048, which is what we needed. Okay, user win GDB server on 0000 localhost airplane. Alrighty. This is interesting. And again, go to the ChatGPT to just get the information about this command. ChatGPT tells us it is a fragment of GDB server command, which is a GNU debugger on a remote machine. So GDB server is allows you to run this program on different machine than on the one where your program is running. Airplane seems to be the name of the executable that you want to debug using GDB server. Well, we know that GDB server is something now, and this is what is running on the port 6048. So let us see if we can somehow exploit it, GDB server exploit. And here on the first we have pen testing remote GDB server. And this article tells you what this GDB server is and how you can exploit it by uploading a malicious executable and then execute it as the GDB server. We're going to follow these exact steps because this is how we do it. So let's just change the LOs to 10.0, which is our tryhackme IP. Our file will be saved as binary.elf. And let me open this in our Kali machine itself, so it's a bit easier for us. Okay, so we are going to make this elf file executable and then launch GDB on this elf file and then use target extended remote, and this is where our airplane.thm will go with the port number. Then we upload it, then we set remote exec file and then just run it to get the reverse shell. Okay, seems doable. So we're going to follow these steps: chmod plus x on binary elf, and then GDB on it. Then again, target it extended remote. So we have this airplane.thm on port 6048. Okay, I guess it worked. Now we are gonna put that. Okay, the previous command is still processing. Okay, paste this. It says permission denied. I mean, we can always paste contents in temp directory. It says successfully sent file. Okay, now we're gonna set the remote exec file to run it to get the reverse shell. Okay, so we're gonna launch the network system port 4444, run, yes, and it should work. We specified port 4444 because that is what we specified in our msfn command. We're waiting for catching the reverse shell. and we do get a connection received. Running who am I? We are Hudson user as we enumerated in the LFI using burp so that we were indeed Hudson, and this is proved right here. Okay, so this is our airplane binary executable. We can verify that. There is ELF. Now I can try executing it just to see what it is. It just says it's a simple program. Okay, we are going to leave you simple program. Okay, so let us go to the home directory. We have Carlos and Hudson user. I'm going to go inside Hudson. And as we can see, we have the app folder here. Let's app. And we have all these files here. We have already enumerated those and there is nothing interesting there. So we're going to leave that. But first of all, we are going to go inside the SSH directory. And we do not have IDRSA here. I guess which is why we were not able to see the IDRSA file because it did not exist. Okay, I'm gonna keep this GDB open in case we lose the our connection. We can just respawn it, use the GDB. So I'm gonna run ssh-keygen and I'll save it as ID in our current directory itself. I'm gonna specify the password as ASD again, and we have our file saved here. Okay, now let us see the IDRS id.public file. Let us copy these contents, echo this to authorized keys, and let us do chmod 600 on it, because if you do not do that, it won't work. And just to prove that point, I'm gonna do Hudson with the ID, our private key, specify the password here, ASD, and okay, it worked. I was wrong. So you do not need the chmod 600 here. That is quite a lesson for me. Alrighty, so I did all of these steps but did not explain why I did it. I did it to gain SSH access onto the Hudson user. So all you have to do is just copy your ID .public file to the remote server on which you want to gain access, and but make sure to name it as authorized keys, not ID RSA.public or something. It should be authorized keys, and then you'll be able to SSH using your private key. Alrighty, with that being said, we have the SSH access, and if I do sudo-l, I do not have the access to Huston's password, so I cannot do that. But let us quickly see if there is. So I'm going to find all of those binaries that may have SUID with set. That is the very first thing I usually do to find a way for privilege escalation. And right off the bat, I can see user bin find. Okay, most of you would be aware of how we can exploit the find command for SUID bit for getting access to the GTFO bin. So I'm going to do the same. So user bin find. I'm going to launch the bash, not sh. I do not like sh. Okay, you have the bash shell here. Let us see which user are we. We are Carlos. Okay, why are we Carlos? Let us see. User bin find. So this find command was owned by Carlos and SUID bit was set on it, which is why we were able to privesc to Carlos user instead of the root user, because it was not owned by root, but it was owned by Carlos user. That being said, now we are Carlos user. Let us enumerate a bit more. Before that, I'm gonna go inside the home directory of Carlos to see what we have there. We have user.txt usually. Okay, and we have all those folders. We can enumerate that. Okay, that is ton of files here. So these are the folders, and all these are empty. Even the SSH folder, Mozilla Firefox we have. So when I saw Mozilla at first, when I was solving this box here, I thought we can maybe find something in Mozilla crash dump, or maybe in Mozilla user profiles that we have here. But this, let me show you. If we go inside this, we have a ton of files here. And usually to dump the saved passwords from Mozilla profile, you need a login.json or login.db file or key.db file. We had a key4.db file here, but it is empty. It is not empty, it contains some contents, but we do not have any login passwords there. So it's of no use to us. So that was a rabbit hole there. So I'm gonna skip that, otherwise it will take a lot of time. We also have this another user profile, which is just empty except one file, which is again no use for us. So we are not going to go inside that ever again. If I do sudo-l here to see what commands we can execute as Carlos user, it is still asking for the Hudson user's password. That's because we don't have a TTY proper TTY shell of Carlos. We are Carlos, but if I do env, we can see our log name is still Hudson. Our home directory is still Hudson. So we are going to do the same thing as we did previously for SSH thing. So I'm going to do the same here, but instead we need it to be inside Carlos SSH directory. And now we should be able to SSH in. So SSH Carlos with the ID file. It is asking for the Carlos password, which it should not. So let us go inside home Carlos SSH directory. Okay, it is owned by Carlos. The group is Hudson, I guess, which is why this is happening. So I'm gonna do ch change the ownership to Carlos for authorized keys. It says our operation not permitted. Maybe chmod 600 will do it. So we did that, and asking for the passwords for key ID ASD, and it works. Alrighty. So the thing is, authorized keys should not be accessible by any other user except its rightful owner, that is Carlos. Earlier it was accessible by Hudson, which is why it did not work. So we had to do 600 to make it only readable and writable by Carlos user. Hudson would not be able to interfere with this file in any way, which is why it worked now. So let us do sudo-l here, and we can now see the output of sudo-l command, and we can see we can execute any command. Sorry, not any command. We can execute Ruby, but we can execute the Ruby script in only the root folder. Okay, so we can use sudo to execute this command. We can quickly check that, and it says no such file or directory. So it usually means that we can only execute Ruby files that exist inside the root folder. And there's a wildcard. And you know what? We can take advantage of this wildcard. Oh, like we did previously using our LFI thing. So if I place these again, we are out of root directory now. Well, if we use single one, we are out of the root directory. We go inside the temp folder. We can say script.rb, and it says no such file or directory. I guess will work if we specify script.rb there. So I'm gonna just do a test here. So script.rb inside the temp folder. Launch this again, and it works. It does not say no such file or directory. Now we just need that Ruby script that would give us a reverse shell. So Ruby reverse shell. We have the result on the top. I'm gonna copy this one, and the nano script, well, it was in the temp directory. This is where our try-hack-me IP comes in, and the port is 1337. So I'm going to launch the reverse shell on port 1337, and then launch the sudo command here, and we catch our reverse shell here, and we are root. Let's see what we have inside the root folder. We only have root.txt and snap, but we solved the box. So that is it for this one. I hope I was able to explain the concepts and you were able to understand it. So that is it for this one. I'll see you in the next one.